Okay, so let's start.
All right. So this is a texture analyzer. It is used for literally anything and everything in food processing, food production, the beauty industry. It's used in nutrition studies. Tim, I know some poultry people have used it to test bone strength. It does a wide array of things, and it is a very important tool in the food production industry. So kind of what we have as a setup here, this is like our main base. This is where we can attach all sorts of things. We have a nice little box here, which each of these things have a specific tool or technique, depending on what you want to do. So what I have on here now is just a cylinder compression test probe. So this is used to get a texture profile analysis, and the texture profile analysis is what you can use to emulate chewing of a food product. So say I had a chunk of a hot dog on here. We could run this. It would do 2 compressions, and you can make settings as to if you want to compress it 50%, 25%, or up to 75%. So that would just, you kind of calibrate it to the height of your product, and then you make it go 75, 25, or 50% of that. And that's just depending on what product you have. So when I did this for my own research, I had egg yolk gels, and they were obviously not like very strong, so we had a compression of 25%, because if we went any further than that, then the product would fracture, and that would throw off the second compression we have to do. So say we had a hot dog in there and we do our double compression. This is the results we would get right here, these 2 graphs. So these are 2 graphs that I had from my personal study, but we're just saying it's a hot dog right now. So like I said, we do a double compression. So this will be our first compression. This is as it compresses, compress to 25%, release. Do the same thing again. So from this graph, we can get a bunch of different measurements to give us our texture profile of our product. So the first thing we can get is hardness, and that's just how much force it takes to flatten your product to your desired percentage. So that would be this here, the force that this is. Next is your cohesiveness. So that would be this divided by this area under here and this area. And that is to emulate your chewing. So if something is very cohesive, that means it adheres to itself, so you'll have 2 similar peaks for cohesiveness. If something is not cohesive, it will fracture or be stressed under that first compression, and the force under this curve will drastically decrease. So this is important for depending on what you want to do. If you are chewing something, you don't want it to be super cohesive, because then you're going to have to chew it very hard or many times to get it broken down to swallow. But say you want something that you want to be structurally integral, so then you want it to have a very high cohesiveness, depending on what you're looking for. The next you can get is springiness. This is important for like a cake product. So say you're like looking at Little Debbie cupcakes or something. You obviously want your cake to be pretty springy. You don't want it to be super dense. That's a bad cake. And again, that's also related to the second compression, and how we have these divided here. We have 1, 2, 3, 4, 5 different phases. So each of these phases, you can divide numbers up and get different ratios to get different parts of your texture profile. So the last 2 that we kind of focus on mainly, there's a wide array, but these are the main ones, are gumminess and chewiness. So these are interchangeable kind of measurements, but it just depends on the type of product you have. So we have gumminess, so that's a semi-solid state. So it would be something more like a jello. It's not firm, but it's not like super liquid. And then chewiness is a solid food, which would be something more like cheese. So that would be something that we would use this type of probe for. And this, which is what I was hoping to demonstrate today, is called a Kramer shear. So we have one that has multiple blades, single blades, all different types of blades we have, little ones. So those are going to kind of determine the energy it takes to like puncture, say, a piece of meat. So like we have a tough steak versus a not tough steak.
Tenderloin.
Yes. So yes. So like a tenderloin versus like a part of the shoulder. And so that's what this would be used for. This is also used to determine optimal cooking times and temperatures of meat. So if you overcook it, it's obviously going to be more tough than if you cook it for a less amount of time or at a lower temperature. This is also used to see how intermuscular fat will play a role in the tenderness versus the toughness of meat. This has been used a lot for salmon fillets in this lab, determining if different feeds, rearing temperatures, and all sorts of things affect the texture of a salmon fillet. So that's what this has been used a lot for. A couple other things we have. Is this? It's kind of
It's for peanut butter.
Yes, so this is meant to measure like kind of like the stickiness of stuff and adhesiveness. It can also be used for spreadability. We have one and it's kind of pointed out into a point, and that can be used for lotions. If you you obviously want your skin creams to be spreadable, or the spreadability of mayonnaise. So you want you don't want it to rip up your bread like a hard butter. You want it to be soft. We went over this. We have. It would be something like this, but instead of a sharp point, it would just be rounded on the end. That can be used to test the texture of bagels, cheese puffs, and it can also be used to see how soft your eyeshadow palette would be. So if you shove it down into an eyeshadow, is it going to crack? Is it going to dent? That helps determine the texture of eyeshadows. Also, if you dip that point down in and pull it up, it helps you determine the consistency of your cake icing or toothpaste. Fun fact. And this also could be used for bagels if you puncture it to see how firm your bagel is. If you want a firm bagel. We went over a shear. Texture analysis has gained a lot of popularity again in the food industry because of the rise in vegan and plant-based meats and cheeses and dairy products. So they want to emulate the textures and the mouthfeels of an animal or dairy product, but with a plant-based kind of formulation. So they use texture a lot they'll make a product, run a texture profile analysis, and see how close they can get to the actual animal product. So that's big now. They're looking at yogurts, cheeses, sausages, because a lot of that stuff can either be super gummy or super firm. It's never they have to work really hard to get a better consistency of plant-based products. Also, another example is your box puddings and your box mixes. So in order to get the perfect directions on the box, on the back of the box, they have to do a bunch of different formulations of you add this much water, this much milk or whatever, run texture analysis on it to see what gives you the perfect product, so they can then go back and write the perfect recipe for you to make your puddings, your cakes, or whatever they give you a box mix for. So texture is very, very important for a lot of industries, and it's continuing to grow because of the diverse food products we have out there. they're coming up with new things every day in the beauty industry, but also again with vegan products and things like that. Or using different types of chemicals or less chemicals. So yes, texture is very, very important. I think that's about it right now.
Okay.
Yeah.
Thank you. Almost out of battery right now, so that's good.
Perfect.
So if I want to check